Hi everybody! So my name is Mrs. Vasta and I am one of the Math 1 teachers here at Maine East. I am making this video to go over some of the notes that go with your 2.3 Ready, Set, Go practice problems. Now the beginning of the notes you may have gone over in class with your Math 1 teacher. If you did this in class already, then your job is to listen very carefully as I go over these again so that it can refresh your memory from what you did in class. If you did not already do this in your Math 1 class, then your job is to take these notes now so that we can continue to do some practice problems once I'm done with this first page. So here we go. These notes are going to be all about the idea of rate of change. When you hear the word rate of change, that is another way of saying slope. And in math, we use the variable m to stand for slope. And the reason we use the variable m is that the slope tells us how to move between points on a graph. So if I was to explain to you what the slope is, I would say that the definition of slope is it describes how to move between points on a graph. One interesting thing that you should know about slope is that your slope is always going to be a fraction. So when we write our slopes, you should expect your answers to usually be fractions. Now you'll notice that in these other boxes, we have a box for finding slope from a graph, finding slope from a table, and finding slope between 2 points. Because we are going to ask you to find slopes in a variety of ways, we're going to go over each of these examples one at a time to talk about how we would find the slope in these different situations. So if you are given a graph and you are asked to find the slope, then what you need to think in your head is that the slope is always the rise over the run. Now you may have heard these words before in your previous math classes, rise over run. But just in case you need a refresher, rise means we are going up or down. And run means we are going left or right. If I were to give you this graph and I said to find the slope, the first step is always to find 2 nice points. Now when I say nice points, what I mean is that we want to find 2 points where the line crosses exactly at the corner of one of the boxes on our grid. An example of that would be this point right here, and another example would be this point right here. And on this graph, those are the only 2 nice points that I can see. After we find our 2 nice points, we're going to make a fraction to find our slope. So I'm going to start from this lower point, and the rise would be how many boxes do I need to count upwards to get to the other point, to move to the other point. I would need to rise 5 boxes. So the top number in my fraction would be 5. Then I would try to figure out how far do I need to run going from right to left to get to the other point. Since I would need to slide over 2 boxes, my run, the bottom number in my fraction, would be 2. Since 5 divided by 2 does not simplify to a nice number, that would be our final answer for our slope. Now, one of the things that we need to think about is that there's actually another way to find slope. So let's just suppose that you started at the top point instead of the bottom. To get from the top point to the bottom point, we would go down 5 boxes. So that would mean that instead of a positive 5, that would be a negative 5, which means the top number of my fraction would be negative 5. Then I would go to the left 2 boxes. So I would make that a negative 2. So the bottom number of my fraction would be negative 2. Now, one of the things we know, the properties of numbers that we know, is that when we divide two negatives, they become positive. So my final answer here would still be 5 over 2. You do not need to do both of these things every time. All I want to do is show you that there are two options. And so as long as you make sure you pay attention to your positives and your negatives, it doesn't matter which point you start with. You should always be able to get the same final answer. Now that we've talked about how to find the slope from a graph, let's talk about finding the slope from a table. For finding a slope from a table, instead of thinking about slope as rise over run, we're going to think about slope as the change in y divided by the change in x. In math, because sometimes we like to abbreviate, sometimes instead of writing change in y, we abbreviate that to delta y, because delta, this little triangle, means change. Divided by the change in x, sometimes we write delta x because that little triangle means the change in x. In order to find the change in y divided by the change in x, we're going to look at the numbers on the table. So you'll notice that the y column is the column on the right and the x column is the column on the left. I like to find two friendly numbers. So if I'm thinking about friendly numbers, I am much more comfortable working with these positive numbers down here than I am with these negatives. At the end of the day, you can work with whatever numbers you think are most friendly as long as you find two numbers in a row. So in this table, let's start with the y values. To go from 2 to 4, my pattern is that I add 2. And to go then on the x column, to go from 7 to 9, my pattern is that I add 2. So what I did is I did that same idea of patterns that I've been working on all semester. I just did a positive 2 and a positive 2. I added 2, I added 2. In order to find my slope fraction now, I put the change in the y, which is a 2, divided by the change in the x, which is a 2. And this time, when I look at this answer, 2 divided by 2 does simplify nicely to just 1. So that would be my final answer. Now let's talk about the last thing, which is how do we find slopes between 2 points? Now, what I would suggest is when we have 2 points like this, I'm going to take these 2 points and I'm going to turn them into a table of values, just like I had a table of values here. That way, I'm going to be able to use this same idea to find the slope between 2 points. So first step is make a table. So I'm going to have an x column and a y column. My first point is 1, negative 4. So the 1 goes here and the negative 4 goes here. That's my first point. My second point is negative 2, 5. So the negative 2 goes here and the 5 goes here. Now I'm going to do the same thing I did in the previous problem. Find the pattern of the y's and find the pattern of the x's. So to go from negative 4 to 5, I add 9. And to go from 1 to -2, I subtract 3. Therefore, my fraction that I'm going to make is 9 divided by -3. Now, 9 divided by -3 is an example of another fraction that simplifies nicely to just be -3. Finally, let's talk about two special slopes. So the first special slope is the slope that we get when we have a vertical line. If we have a vertical line, we say that our slope is undefined. And our second special slope is if we have a horizontal line. If we have our horizontal line, we say that our slope is just 0. All right, let's go ahead and just do a few quick practice problems to make sure we've got this idea of slope figured out. So we're going to start by doing problem 1 together. For problem number 1, I have a graph, so I'm going to think about slope using the idea of rise over run. Now you'll notice that on this graph, we've given you two nice points on the graph. So what I'm going to do is I'm going to count how many boxes I need to rise. And in this problem, I only need to rise 1 box, so that goes on the top of my fraction. And I'm going to count how many boxes I need to run. So I need to go sideways to the right 2 boxes, so that goes on the bottom of my fraction. Since the number 1 does not divide nicely by the number 2, that's my final answer. Next, let's look at problem number 5 to do one more example with a table. When there's a table, instead of thinking about this as rise over run, I'm going to think about it as the change in y divided by the change in x. So from this table, let's start with the y values. To go from -21 to +28, I need to add 49. There we go. To go from -3 to +4, I need to add 7. So my change in y would be +49, and my change in x would be +7. When I divide those numbers, they do divide nicely. 49 divided by 7 is just 7, and that would be my slope. Finally, let's try one more example like problem 8, where you have 2 ordered pairs. The first thing I'm going to do here is I'm going to make a table. So I'm going to have my x column and my y column. My first ordered pair is -2, 3, and my second ordered pair is 1, 5. Now I'm going to go back to change in y divided by change in x. To go from 3 to 5, I have to add 2. And to go from -2 to 1, I need to add 3. So my change in my y would be +2, and my change in my x would be +3. Since +2 does not divide nicely by +3, that's my final answer. Last but not least, if you turn the page, there's another thing we can do using the idea of slope, and that is use the idea of slope as being how we move to figure out how to make a graph. So, in this problem, I'm given a starting point and a slope. My starting point tells me where to begin. So on my graph, this tells me to begin at the point 1, 5. So I would go over one spot and up 5, and that's my starting point. My slope tells me how to move. Because the top number in my slope is 1, this slope specifically tells me to rise 1, and then, since the bottom number is 3, it tells me to run 3. So from this point, I'm going to rise 1, go over 3, and then put a new dot. Then I'm going to repeat that pattern. So rise 1, go over 3, put a new dot. Rise 1, go over 3, put a new dot. I could also repeat this pattern by going backwards. I'm just going to reverse. So instead of going up, I'm going to go down. Instead of going right, I'm going to go left. So down 1, left 3, down 1, left 3, down 1, left 3. As you can see, all the points here line up in a nice straight line, which they should, because all of my points are using the same slope, the same movement. So if I wanted to, using a straight edge, I could connect the dots to make a nice straight line on my graph and get a linear function. All right, guys, thank you so much for watching, and we will see you in class for some extra practice.